Okay, so for number 4, this one's a little bit different from ones that we did in the first video too. It says the owner of a ranch decides to enclose a rectangular region with 140 feet of fencing. To help the fencing cover more land, he plans to use one side of his barn as part of the enclosed region. What are the dimensions he should use for the length and the width, and what is the maximum area that the rancher can enclose? Alright, so the way that I'm going to do this, I'm going to draw me a picture. So here's my barn. And so the fence that I'm going to make, or the lot that I'm enclosing, is right here. Okay, so one side of that barn is part of that enclosed space. So whenever I go to label this, I know that I've got 140 feet of fencing, and that's all I've got to use. Now, another thing that I know is that since this is a rectangle, this side and this side are going to be the same. And since I don't really know anything except that I've got 140 feet of fencing to use, I'm going to let this be X and X. Okay, so they're the same, so they're just both X. Now, let's just pretend that, to make this math easy, I'm just going to pretend that I've used 10 feet on each side. How would you find out how much I have left over to use for that last side? Well, I would do 10 and 10 make 20, and then I would just subtract that from what I have right here. So that'd give me 120 feet left for that last side. Well, since I don't know that they are 10 feet, I'm going to use my X instead of that 10 and do it the exact same way. So I'm going to take, if I have X and X feet of fencing that I've used here, that's going to be 2X feet of fencing that I've used so far. And I'm going to subtract that from 140. So that'll give me what's left over for that last side there. Alright, so now it says, what are the dimensions he should use for the length and width, and what is the maximum area that the rancher can enclose? So I'm going to set up my equation. Length times width would be X times 140 minus 2X. And so I'm just going to plug that in the calculator, and since it's asking us for the maximum area that he can enclose, and this should be worded a little bit better, this should say what are the dimensions that will create, that he should use for the length and the width that create that maximum area. So we're just going to go ahead and plug that in and find the maximum. So I'm going to clear that out. X times 140 minus 2X. And then I'm going to zoom 6. I'm probably going to have to change this a bit. I don't see anything. Okay, so if you don't see anything there, then you can try zoom fit. I know that the maximum area is going to happen up higher, so I'm going to just make that max, or this X max, not X max, but Y max a little bit higher. So this is just something where you kind of have to just play around with it. I'm going to try 100 and see if I see anything. Okay, there's a little bit. And I also know that if I'm looking for a dimension, that's a positive number. So I also need to see out here a little ways, okay, because the maximum is going to happen somewhere out here on the x-axis. So I'm going to make my x-max a little bigger too. So I'm just going to go 50, we'll pretend, and then I'm going to change this number and make it even higher. See if that helps my window at all. Okay, does a little bit, but looks like both of those numbers still need to go a little higher. So I'm going to try 100 for this, and I'm going to try much bigger here, 1500. Let's try that. And you can see that's not going to, well, it works for this, okay, and then I'm going to go ahead and make this, let's just make it 2500. See, make sure we can see that maximum. Alright, now, like I said, I'm going to word this better, or I'll make sure that problems that I give you are worded better, but what I want you to find on this one are what are the dimensions you should use for the length and the width that create that maximum area. So what I'm going to do is, not go there, go to this function and find the max. So that's the first thing. So I'm going to go to the left and the right. There we are. Okay, so this, because in our formula here, x represented the dimension for the width of this thing, when we find x right here, that's going to give us the width that we should use to make that maximum height, and that was 35 feet. Now, the length I'm going to find by doing 140 minus 2 times 35, and I'll find that in a second. But I'm going to go ahead and find the maximum area since we're there on our calculator. And so if this is the dimension that I use, then the maximum area that will create is 2,450. And that is square feet. And so then you can probably do that in your head to find the length, but if not, I would take 140 minus 2 times 35, and so that would give me 70 for the length. And you should be able to check this. 35 times 70, if you go back to your calculator, woo, gives us 200 or 2,450. So that should work, so you can check yourself. Alrighty, number 5. Alright, so you should pay real close attention to this problem because there was a problem on the exam that was real similar to this. So you should watch this one and like put a star by it. But number 5 says, an object is launched upward from ground level with an initial velocity of 70 feet per second. The height of the object t seconds after the launch is given by this function. At approximately what value of t will the object have a height of 50 feet on its way down? And then part B says, at approximately what value of t will the object have a height of 50 feet on its way up? Alright, so I am going to plug this in my calculator. And I'm going to show you the easiest ways I think to do this so you can kind of visually see what's happening with this function. But I'm going to plug this in. This is negative 16. I'm just going to use x for t. And then that was plus 70. Plus 70t. Alright, so there we go. So I'm going to zoom 6 it. Can't really see anything, but I can see where it's going to come down at, and this is negative, so it's going to be like a mountain. But I'm going to go change this here window in my Y max and make it, let's go 100, just to be safe. Alright, so then here's my graph. There we are. Now, it says at approximately what value of t will the object have a height of 50 feet? So now, if we think about this in terms of x and y, or this function in terms of x and y, t is like my x and h is like my y. So they're giving us a y value, a height value here of 50. And so what I'm going to do is go plug that 50 into y2 and graph it. Now, you can also kind of see from this function that if this is launched from ground height that's starting here, it goes up and it reaches its maximum height and then comes down. And you can see that it's going to hit 50 feet for its height on its way up and on its way down. And so for the first part, this is asking for on its way down. So I want to find where this straight line of 50 feet crosses this parabola here on its way down at 50 feet. So I'm going to find an intersection. So I'm going to find number 5. Now it's going to say first curve, second curve. You just need to hit enter, enter, till it actually, that's going to find the first one. Whatever you're closer to is what it's going to find. I need to go find the second one. So you need to move your cursor just closer to the intersection you're looking for and then hit enter, enter. And so then that's going to give me, you can see that the height is 50, but that's going to happen at 3 point, and I'm just going to round that to 5 seconds. So at 3.5 seconds. Alright, part B, on its way down, or on its way up, it wants to know what that would be, so I'm going to go do the same thing and find the intersection. And this time just get closer to that first intersection and hit enter, enter, enter. And so that's going to be at about I'm just going to round that to 0.9 seconds. Alright, now what is the maximum height of the object? So now on my calculator I'm going to go find this maximum height. So I'm going to calculate the max. I'm going to go take that 50 out first. I don't really need that anymore. And so then I'll find the maximum height of this function. So max, just like we've been doing. And my maximum height is going to be given by the y value. So I'm going to round that to 76.6. And that is going to be feet. So 76.6 feet is the maximum height. Now it wants to know when will the object reach its maximum height, and so that is going to happen at this x value, which is like our t value, so that is basically 2.2 seconds. And then last one, E, it says at what time will the object hit the ground, and so it's going to hit the ground right over here when it crosses the x-axis, and so I'm going to find or calculate a 0 and go to the left. That would just be there. And then the right, I want to make sure that y value is negative, it's below. And so then there would be where this is going to hit the ground. So this is at 4.375 seconds. Alright, so that's how we would do that one. Okay, last problem, and this one's a little bit weird, but it's a good problem and one that I've seen on the test before, or one similar, so we need to make sure we know how to do them. But this one says, a polynomial has roots a and b. Find a and b such that a plus b equals 5 and 1 over a plus 1 over b equals 8. So on this one, the way that you're going to have to do this is by solving this first equation for a variable. Doesn't matter which one, okay, either one. I'm going to solve it for a. So I'm going to say a is going to equal 5 minus b. And so then I'm going to take what I just solved for a and I'm going to plug it into the second equation where a is. So this is going to be 1 over 5 minus b plus 1 over b equals 8. Now this should look real familiar because we just solved those whenever we solved our equations in our first couple of lessons. So the way that we solved this, we said the easiest way was by finding what the common denominator, what that common multiple would be for these two factors. So I would need to multiply this by a b and a 5 minus b. And I'm going to give it to each one of the terms. So to there, and to there, and this is like an 8 over 1. Alright, so when I give that out, the 5 minus b's will cancel out, and I'll be left with just a b. And then when I give it to the second one, the b's will cancel out, and I'll be left with 5 minus b. And then when I give it to this third one, nothing will cancel, and so everything will be left. That'll be 8b and then 5 minus b. Alright, so then this is what I'm going to work with and solve. So the good thing is the b's cancel out over here, and I'm just left with 5. And so then this would be 5 equals 8b times 5 minus b. Now, roots. Roots are just another word for zeros. So what I'm going to do is subtract this 5 over. I'm going to come over here and do that and set this thing equal to 0. So 8b times 5 minus b I'm subtracting the 5 over. So if I subtract that 5 over, I'm just going to stick it on the end there, equals 0. Now, to solve this or to find the zeros, I'm just going to plug it into the calculator. And so when I go plug this into the calculator right here, I'm going to plug it in exactly like I got it to make my work a little easier. So this is going to be 8b times 5 minus b, then minus 5. So I'm going to plug that in as 8x times 5 minus x, and then minus 5. And so then when I graph this, I may have to change the window. I could probably do it from here. So I'm just going to go ahead and find the two zeros. So 0, 0. And so the first 0, I want you to write it as a point. So this is going to be 0.128 comma 0. So 0.128 comma 0. And I'll erase my arrow just a little bit. The second 0 I'll go find over here. So second calc 0. So I'll go to the left, go to the right, and so that second 0 is going to be at 4.871 or 4.872 if I round it, comma 0. And so polynomials has roots a and b. Find a and b. Okay, so a and b would be, this would be a, this would be b. And it really doesn't matter which one will be which, because on the exam they asked you to just write the zeros, and so these would be the zeros. So either one of these numbers, this could be a, this could be b, this could be b, this could be a. It just wants you to find the two numbers that make these equations true. So if we were to go add this and this, I would get 5. And if I were to do 1 over this plus 1 over this, it would give me 8. Okay, and I could switch that and it would still make these two statements true. So now it's saying, what is the equation of the polynomial that has these roots? Basically, we're going to know what that polynomial is by taking that and just simplifying it. So I'm going to distribute the 8b. So this would be 40b minus 8b squared minus 5. And so then I would just write this in standard form. And so here would be the polynomial that has those zeros.